luck. Good to meet you. Bye.
Bye.
Could we quickly make a slide?
Yes. Are you volunteering?
Oh, I have text.
Multiple here on sec. I'm changing that. Okay, so what do we want to make?
I can do the slide if you're doing something else, Alec.
I'm just getting pings and stuff that are,
Yeah, let me do the slide then.
Okay, well, actually, Craig, you should tell me whether or not this is like too. I'll put it in the Skype chat, actually.
Okay.
And I have to make sure that that first name is not spelt right, I don't think. You know, that quote?
I don't know that quote. This is my first time seeing it. Yeah.
It's a great old time quote, I think. And the real spelling of the guy's name is that.
Oh, okay. Is that?
No, because what reminded me of that is computational thinking isn't about computer science.
Yeah.
And I think that's a very hard point to make, because when Jeanette Wing first introduced the word, she described it in a way that was very CS-esque. Right, she backed away.
Yeah.
What she ended up saying was something closer to what Wolfram said, and this would be the other thing that I think we'd want to put on a slide. Okay, so this is from Wolfram.
Do you want this on another slide or on the same one? Probably too much text on one.
It's probably too much text on one.
Yeah.
Do you know this quote? I've been handing it out to people for a while. You know, because I think this is a better summary of what it says than anything that I've seen from Wing. You know, though it's consistent with her second definition of it, though. You know, because for the first wave of people talking about computational thinking, it was really CS0.
And this is, you said this was Stephen Wolfram?
Stephen Wolfram.
Yeah.
Okay. I gotta quit this.
Oh, you even corrected the spelling mistakes.
Yes, I did. Well, fortunately, spell checker kept me honest.
Oh, okay. I usually am cleverer than that, and I make mistakes to get through the spell checker.
Just for clarity's sake, I'm just going to break this up a bit just so people can read it a little easier.
Because originally, to a really CS geek crowd, my quote could have been, computational thinking is no more about computer science than astronomy is about telescopes. Because most people who are like really old school CS people knew that quote.
The telescope one?
Yeah.
Yeah.
Yeah, a famous quote whose fame has been evaporating as time goes on.
Yeah, I think this works. All right.
I'm gonna need a serious detox after this because I'm part of so many groups right now in chats. I have pings and like all kinds of beeps. I don't know where the sounds are coming from. Too many tabs open. Ugh.
When does it all end?
Yeah.
Today.
Okay,
Today.
Then I can just enjoy stuff.
right. But you know, the bad thing is Rustics kind of crashed.
What's that?
Rustics is no longer what it used to be.
Yeah.
You know, that the last time we walked by there, they weren't serving any food and the only beer was Bud Light.
Yeah, I mean that I mean that was a fun place to go hang out, but
Yeah, no, it's the sort of place that I think is totally appropriate for
for a post
situation.
post workshop
for-
session.
No, Craig, we probably told you about this. It's a bar that, when we go there, I think we're the only people who are gainfully employed.
Oh, okay. So it's a dive bar or hole in the
Oh,
wall.
it's a complete, what it is, it's a dive and you know, it gets to the so bad it's good part.
Mm-hmm. Yeah.
I remember the food being half decent though for pub food.
No, the food's pretty good.
Which place did you take me to, Brian? We went to a place that was just we got beer and poutine. Or I got poutine. I don't know if you did, but it
Sounds
was
like
so
Rusty.
Oh, no, that was a decent place. I think that was Mambolduc. It was a fair bit of travel.
Yeah, it was right. It was it towards the east side of town?
Yeah,
Or, I don't
and
know. Yeah.
that I think changed ownership. They remain about as good, but now
Hmm.
now it's got a veneer of respectability that you know that it was trying to be Paris and doing a bad job at the
I
pretend.
see. Yeah.
Artemis and I are both fans of the combination of looking like a dive and good food.
Yeah.
Okay, but the questions that I was asking, is they're all of the form of, you need to think about this versus that,
Mhm.
right? You know, why blocks instead of text? You know, how do you decide between Scratch, Snap, and Logo? You know, how do you think about Logo, Python, MicroPython, C, Java?
Those are
Right.
good questions.
What hardware? Microbit, CraftyBit, Arduino, Raspberry Pi?
Yeah.
You know, do you want microworlds? Do you want complete systems? And
Yeah.
the thing that I think we keep getting back to in our discussions is we're not trying to be everything for everybody. We just are in a corner of the overall space.
What? Yeah, what happened to the the micro worlds idea? That didn't grow with the constructionism the way that maybe.
Well,
some-
it never, it's an interesting debating point, and since part of you is being an academic, you could almost dive into that yourself. To a first approximation, Seymour was promoting microworlds, but he never did it. All LCSI products were complete systems.
Okay.
Yeah, and hi Josh. I shouldn't say all LCSI products because I kind of spearheaded a couple of them that weren't.
Yeah.
And with the Scratch team, the Scratch wants to be a complete system.
Did it
You
from the
know,
beginning,
it's-
Brian?
I beg your pardon?
Did it want to be a system right from the beginning, or did you see it start
Yeah,
as more of a
because
micro? Yeah.
Mitchell didn't want to. Mitchell wanted to do wide walls. The idea of
Yeah.
doing narrow walls. You know, microworlds. The characteristic of microworlds is fairly narrow walls. And the thing about it is, it's kind of you know, the running joke that I think you've heard me told is what Scratch is trying to do is it's trying to have something for everyone. And when you try to do something for everyone, you could, in cases of good things like Scratch, get about 85% of the people. And I always thought my job was to make things for the other 15%. You know, that it's basically And this is really in terms of, how do we get this stuff out there? I was meaning it quite seriously. Most people out there will not want this because they say, logo, that's stupid. The kids need to learn Python, right? Let's just not try to convince them, because there actually is a community of people that question isn't even a question.
Mhm.
And what I think we need to do is find that community. And I remember having a conversation with a marketing person who said to me, but that may only be 10% of all teachers. And I said, yeah, but there's typically one of them in every school.
Mhm.
Mhm. Yeah.
Yeah, and getting those together is an important thing.
And getting them together is an important thing. And I think because of that, it may be good to be very consistent about the message of not trying to say, well, I want to make a video game, right? And we'll just say, okay, let's just add 2 more primitives to enable making video games.
Mm-hmm. It's also, I mean, just for even non-programming teachers, like just if let's say you have a student who wants to have something light up, well, wouldn't it be nice just to be like, here's 3 lines of text that'll get you started?
Well, we should debate this when our friends have arrived, because I think the majority of people would prefer 3 blocks. And I think that majority may not include me or you.
Mm-hmm.
Right, that I think that it's widely perceived that the blocks language is simpler in a way that makes it inherently better.
Mm-hmm.
Now, where logo, we were spinning around the question of why logo rather than a blocks language. The thing that logo is much better at, and we saw that with the examples that we were all spontaneously doing, is Alec, you said you build your own library and then you use the library. Mm-hmm. Logo is way better adapted to defining a little vocabulary for your project. And building the project up by building up a lower level vocabulary, middle level vocabulary, and a high level vocabulary, where that kind of modularization in blocks language is possible, but it feels like it's cutting against the grain.
Yeah.
And actually, Kreg, which hats are you using, the Paula style or the Mitchell style?
In what way?
The Paula projects, the hat block is like in Turtle Art, where in Scratch, to get a hat block, you have to go through a dialogue.
Wait, what do you mean? Do you mean like make a block?
Yeah, make a block. There's no make a block in Turtle Art. You just drag out a hat block and put a name on it.
Oh, right, like a define, yes.
Yeah, yes, so it's kind of like it's kind of the way Scratch did it, even worse than Snap. Make a block feels like an advanced feature.
Yeah, and make a block cannot be a hat block. It's only a command block in Scratch. So you actually can't technically define a procedure the way you would traditionally think of it.
Well, the language could have been designed to make that possible. Given that what we're doing, given that what we're doing is single-threaded, we could use the Turtle Art approach, which that approach in a blocks language is what we did in ArtBit. Yeah,
and that seems sensible for something like this. Yeah, we should prototype that.
Yeah, but it gets back to why the text language just feels better for mid-sized projects. But Josh, you've used both extensively. What do you think?
So this week I actually taught a workshop for, I think they were all in middle school, in both Turtle Art and Art Logo. So we started with blocks, and then the next day took some of our block creations and translated them to text and played with Art Logo. I think that the benefit to blocks, as we've discussed, is that the barrier to entry is super low. I think that when you start dealing with text, it's much easier. For example, we programmed a dot procedure that we could also tell it what size, what color, and what shade it was just by changing those 3 inputs. And that's easier in the text language. I also feel that a little light went off in the kids who had JavaScript experience, when I told them day 2, we're going to be working with a text-based logo version, that they kind of relish the challenge of needing to keep track of the syntax, needing to keep track of brackets. And that wasn't for everyone, but as you said, if we're getting that 15% that does crazy things like what Sydney did with Turtle Art a few years ago.
Whatever happened to her?
I wish I knew.
She hasn't won a Nobel Prize yet, has
Not
she?
yet, not yet. But we should share those images later.
We should. One of Josh's students did an image that was brilliantly done at all levels. It was an artistically wonderful piece that was implemented in super clean code, encapsulating some totally unexpected math. And I asked Josh where this is coming from, and it was just like a student, 5th grade.
She was an 8th grader.
8th grade, an 8th grade student with no prior background in anything relevant.
Here, I'll open it up in Turtle Art and share my screen.
Yeah, I wanted to hire her, but it would have been illegal.
Yeah, I explained he had to wait till she graduated high school.
So I'll just I guess start the session now. I know that we might be getting some, and then Josh maybe will show this in just 2 seconds.
Cool. Yep.
Just because I see we've got a few more, and I'm sure a couple more will trickle in. So those who have been with us, so Dean, you've been with us the whole way through. Thank you for doing, and a few of you actually have been with us the whole way through. I appreciate you taking the 3 sessions out of your Fab 16 schedule to hang out with us. What I would like to do, so we'll have Josh, you'll show us what we're just talking about, that example. And we're going to do a bit of a show and tell before we go into a little bit of a conversational deep dive into choosing the right tools for the job, I guess is the best way to describe it. And specifically when dealing with creative coding and electronics, and how we, do that in an educational setting, and perhaps even, in personal projects. So yeah, so if you have something that you've worked on, I know there's a couple of you on here, that'd be great to show. Kreg, you showed something just before. I don't know if that's something that you can show. Are you, sorry, Kreg Hanning, because there's another Kreg in our Fab Lab.
Oh wait, I had something to show?
You showed a cool picture. I'm not sure if you're allowed to show the one from the museum.
Oh yeah, sure, yeah.
So that could be something to show. I know Kreg, the Kreg in our Fab Lab, he's our lab technician, has been working on a really cool project this morning that he can show us. And does anybody else have something? You can just put it in the chat, and then I'll see if you can share your screen and show us what you've been doing. So why don't we start? Josh, let's do, sorry I interrupted what you were going through there, but if you want to just do a little backtrack as to what you're about to show us.
Sure. So Brian was asking about experiences with blocks versus text programming. And I explained that I had taught a workshop this week with middle school students using both Turtle Art and then Art Logo. And then of course our memory floated back to a student of mine who several years ago as an 8th grader programmed these images here. So this is the first one that I sent off to Brian, that when we run it. And so she did that, and Sydney is an artist, clearly. But this was really her first shot at sitting down and doing anything in Turtle Art. And she turns this out for us. And then the second one, unfortunately, doesn't look good when you put it on an LCD projector, but it looks great on the screen. And what I like about both of these is that there's randomness built into it, but she's achieving the same result with the code that she's chosen. And it's just breathtaking, like that she's able to do that. And it's also testimony to the tools that Brian and Paula have built that allow a newcomer to capture her vision so easily.
And actually bring up something that's, I think, really interesting about randomness. What she's doing though, she has a goal, right? And I think that's something that often is very important to set up. And I remember, I think I was reading one of Marvin Minsky's essays and talking about setting a goal is important in tinkering, right? Or at least in your project. I mean, you can tinker without a goal, but if you have a goal that sort of frames your direction, it really kind of pushes you. It's like a constraint. Okay, so
I'll show just one more thing since we're talking turtle art, and then we can shift gears. One thing that I showed the students today is both times, yesterday and today, before I went on stage to do my to-do, I took photographs of first the tiles in the restroom, and today the doorways of the stalls had an interesting design on them. And so we worked out that design in turtle art. I'm going to show you the door design, because what I showed the students, we started with this design, and you know, we didn't want a solid background color because the light reflected off the textured background on the surface. So we tried to capture that with repeating a ton of times with a tiny pen. And then this was my opportunity to show them how to build a procedure with an input that we could change the square size quite easily. But what I showed them with this particular design is something that I do as an artist in turtle art quite frequently, is in tinkering with the numbers. So I explained, this is like you're looking at the art, you know, at this detail, looking at the art closer than the docents like you to be. And then I changed the numbers a little more and we're farther away, and change them slightly more. And now the docents might be, you know, happy with how far away we're standing. And then finally the original image again. So the tinkerability of code is really nice in that you can iterate quickly on a design or a theme and work your way through it. You know, sometimes with some serendipitous discoveries along the way.
Brian, there's a design decision there that you guys have made that I'm curious about. You decided to put the blocks on top of the image.
Yes,
What's the thinking behind that?
that's where they go. Sorry. The thinking behind that is are we allowed digressions? The answer to that question is the origin of turtle art.
Okay.
Okay, we had done Pico blocks for the Pico Cricket, and the programming space always felt a good size. Then in the early Scratch prototypes, I always felt that things were all scrunched, that you were constrained to a little corner, and the stage wasn't big enough, and the blocks canvas wasn't big enough. And it's a long story that ended that Paula wasn't really involved in the early Scratch team, but she was at the, we were accidentally in Boston and ended up at a design meeting. And Paula just said, everything's so squished, right? I said to Paula, you know, this isn't a fair comparison, because with Pico blocks, the work is on the table. What we should really do is put together an app where the work has to share the screen with the blocks. And I'd just been rereading the early logo papers. So I said, why don't we just bring the turtle back as a design exercise to see what it would be like to have the blocks and the work go together. So it turns out that, you know, Paula is like faster in coding than any 15 other people. We got the first prototype going, waiting for a plane at Logan. And what happened was, by 2 or 3 days later, we had something that was so fun to play with that the Pico Cricket, as a company, we were in a state where we were just waiting for approval. So we really didn't have much to do. So we were sitting around for a couple of months making turtle art and improving the app. And, you know, the thing that was intended to be a design exercise just ended up being something that we all ended up very much liking. So there's a really, really interesting design principle in that one, is you can't please everybody. And I know that when I suggested to Mitchell that we think about putting the blocks over the stage in Scratch, he got angrier with me than he'd ever been, because, you know, I said, why not? He says, that's not where they go, right? And I was unhappy with not having sufficient space. He was unhappy with having something covering something else. And a friend of ours who worked at our company for a bit, who ended up going to art school, Chad, Chad's principle on this was he basically said, there's this little thing called taste.
Yeah.
So
a taste decision.
It was a taste decision. Long-winded answer. The answer is because I'm willing to trade off the work being covered in order to have a big place to put all the blocks.
Got it. Okay, so I guess right now, maybe for those who just joined, if you have been with us during the week and you want to show something you've been working on, we'll do it. We'll start now. So I know that there might be a few. Dean, you said you have something.
Yeah, I had some bits and pieces of cardboard that I cut out a decade ago and almost threw in the fire last week, but fortunately I didn't toss them in the fire just yet. And then I also had a microbit that I hadn't really been using much, but I saw that that's something that you had used and I could put an implementation of Scratch on. I found out a little bit late this morning, I couldn't get things working on my other computer, and that's because it didn't have Bluetooth. So about 9 o'clock this morning, I got the damn thing to work. Oops, and of course the clips are coming off here. Let me see if I can. Oops. We'll see what goes here. These things never work when you're live, do they?
That's I don't think I've ever had a like a project in university that I had to show where things worked exactly as you wanted. It's always
okay. So I was trying to make a barber pole. I don't have much use of a barber these days, but anyway, I had a column that I made a decade ago with cardboard. I just cut some press fit pieces. And then I happened to have a reel of some addressable LEDs. And so I saw that there was a way to program those. I didn't, like I said, I didn't have a chance to use your CraftyBits implementation. That's next. But basically I, put a red and a blue, and then I kind of have some white cycling through that to try to give the impression of it spinning, although it's not quite there yet. But anyway, that's the start. Yeah.
Yes, that's great. Thank you for sharing. That's great. And so this is a chance to show what you've been working on also, but if there's like a technical, like something that you've been working on that isn't working, you have a question about the CraftyBit, we can do that now as well. George, hi.
Yes, hi Alec, how are you doing?
Good, you?
Hi all. Yes, I did actually like some tests with the CraftyBit, but the thing is like I'm not too much into programming, so I had some difficulties, but I was managed like to control the servo by potentiometer. Also, I was like able to control the LED strip you gave me, but I was able more to control the brightness of the LED. I did build this yesterday.
Oh wow!
It's it's a turtle out of cardstock.
Yeah.
So, and I did the fabrication on the Cricut machine. Okay. So I have a question, like a technical question. Actually, like I have two questions. The first one is I was not able to use the blocks. Okay, because I don't like, there is a communication problem with the board using the blocks. So I was doing the coding through the code. Okay. The second thing, I just have a question like regarding, can you program this board, okay, if it's not connected through micro USB? Let's say okay, I have like, I'm doing like art installation, and I'm teaching kids how to program things, okay? And the board itself is inserted into this model, okay? I want like to communicate with the board, to upload the code to the board, okay, through Wi-Fi. So I think this would make like programming more interactive for kids. So I don't know like if this is feasible or not.
Craig?
Yeah, so so just maybe where to start. We can do some, if we have time today during the session, we can do some debugging together and see if we can use the blocks language, because that should be able to communicate with your board the same way the text-based language does. But then about the wireless programming, we've prototyped a version of this board that is programmed over Bluetooth instead of over USB. And we're really excited about that. We think that's probably another great strategy. There are some challenges with programming over Bluetooth, especially in a group setting. If you're in a classroom setting, having a bunch of Bluetooth devices, trying to get the pairing process down can be a tricky thing. But it's not to say it's not very valuable, like you've mentioned. You know, once you put the device inside of something you're making, you don't want to have to physically go and attach to it anymore. So we're definitely thinking a little bit about how to implement that. You know, we could just do the traditional Bluetooth model where your device connects to the board directly, but we're also thinking maybe more broadly than that, where we might have one of these devices that's able to communicate to a whole network of them in the same room. So then it's just, you know, a single Bluetooth device that's sort of facilitating all of this communication. I don't know, I'd be curious about your thoughts around Wi-Fi. We're probably, I think, you know, I probably have a stronger feeling about this than others, but especially in classroom settings, you know, when you're in like a museum or somewhere that has their own enterprise network, Wi-Fi can be a real challenge, and connecting to Wi-Fi, providing IP addresses tends to be kind of a messy experience. So for that reason, I tend to lean more towards Bluetooth for wireless communication, but I'd be curious, you know, others' thoughts around that. But definitely having one of these devices that you can program wirelessly will be something we'll have in the future. And some of the videos I'm going to be showing that I've been collecting this week from a science center in Switzerland, they've been using a Bluetooth version of this board to do just that. So they have the boards up on a wall mounted, and they're having kids sort of walk up and reprogram them without having to go and physically attach themselves to the board. So definitely something we're interested in and will likely have a solution for in the future.
Okay, great. Another question, like quick question. Is there a way like for committing like text code? So if I want, let's say, to disable a code, okay, from the text programming. So is there like a way to disable it? Because now like I'm using like, I was like using like cut and run the code. So is there like in JavaScript, you comment like a code?
Yes, we do have comments in there, and yeah, I don't think it's included in the documentation, but it's a if you put a semicolon at the start of the line here, I'm just loading it up right now. I can show. So when you're writing your code, like say you had a procedure over here to start set servo 90, wait 100, end. You could just put a semicolon at the start of this line, and then that would become a comment.
Oh, okay, great.
Yeah, yeah. So
thanks.
And I don't know, Brian, does that the semicolon for comments, does that just come from the logo world, or is that something you had arrived on?
Yeah, it actually comes from, believe it or not, there was an era about a generation and a half ago where semicolon was the standard commenting character in many languages.
Mm-hmm.
Would it be, would this be a thing where you're breaking some rules if you use backslash? Because that's what a lot of other.
Yeah, but there's like two standards now, because there's also number sign.
Yeah, and you got to and dividing. Yeah.
Yeah, dividing. I mean, you know, double backslash could be avoid that, but yeah, since you can type things like this.
Yeah.
Where I don't think, yeah, semicolon's not used for anything else right now in the language, but.
And Craig, while you're on there, just because there's a couple new guests, could you just show the blocks side?
Yep. So we'll jump over to blocks here.
And so if you're switching from blocks, you can, yeah. So George, we can, if you stick on later, we can figure out maybe what was going on with.
Okay.
Yeah, we can maybe try to do some pair programming and see if we can get yours up and running with the blocks.
No, but it's just the wireless connectivity is something that I think we all want, including us. What we found is the reality of classroom environments is there's just hurdles put in your way. And in the case of Wi-Fi, Kreg, I kind of agree with Kreg, as we've developed a lot of things, but deploying a Wi-Fi based anything in schools is really, really, really hard because the IT department doesn't want to let you connect.
And Shelley posted a question on the chat too, that she was using robot in a can, and connecting it through Wi-Fi can get a bit tricky, switching back and forth when she wanted to look up ideas from the internet. So I'm not sure what you mean by looking up ideas from the internet, but I get the jumping in and out.
What Ben did with Robot in a Can was really clever. Is the gadget is not acting as the computer; it's acting as the IT infrastructure. Okay. So you connect to the can, you connect to the Robot in a Can board rather than connecting to the classroom server. Okay. Which gets away from all of the IT problems, but then you don't have the internet.
That's what I was meaning, was like I'm really quite novice and was trying to get a servo working with a microbit without a breakout board, and so I went to other technology, and yeah, I'm not going to show my robot because it's quite disastrous, but yeah.
It's still in its can.
Well, no, I ended up taking out the cans and using a microbit with the PlushPal app, and it's supposed to twist around. My mom has Alzheimer's, and so I was kind of trying to play off of mind the synaptic gap. But yeah, it didn't work. That's okay. That's very tech.
It's very normal for things not to work. Yeah.
Yep.
So I don't know. I'm going to see. I'm not sure if he's listening, but Kreg at LCC, do you have something to show? Let's see. Fab Lab 01, I think, is the one. So we'll see if he connects in a sec. Is there anybody else that wants to show something they've been working on?
I had a quick question for Kreg Hanning.
Yeah.
Is it possible that the color numbers on the CraftyBits aren't lining up with reality? I was trying to set them to like 30 and I was getting a magenta. And then when I went up into 70 something, then I finally got the yellow that I was looking for. And I rebooted my computer and everything. But
yeah, we'd have to look at the code, I guess, because it should be pretty right on with the colors. Okay. And I know sometimes there's a discrepancy with the colors you see on a screen versus the LED colors, but not that much of a discrepancy when magenta is yellow.
Josh, they really should be the light logo colors.
It's that's what
same internal definition.
That's the model I was working under. So okay, I'll load it back up and see what happens.
Great.
Thanks.
So hi, Kreg. So I just want to introduce Kreg in Fab Lab 01. He's our lab technician, and so he's been playing around this morning on the laser cutter.
So yeah, last night I was playing around designing basically a robot arm to be using the boards. It uses an analog feedback servo, and it uses an LED. I don't know if you can see. It basically uses that. I don't know. I haven't gotten too far with it, but it lights up and it spins. So
can you show the way the CraftyBit is nested in there?
So if I pull it off, it actually nests like that.
Yeah.
And there's actually two of them in there. One to control the bottom servo, so it rotates like this. And then one to control the top servo, so the arm goes up and down like that.
So I think for our design class, that's going to be a big part of like what I find interesting with the CraftyBit too, is just how it's sort of designed to be embedded in a way, and eventually when the communication between other bits is there, that could be really exciting.
I really like the size. The size is a good size for this.
And Dean, you were commenting on alligator clips. So I struggle with alligator clips all the time. I hate working with alligator clips, and that's another feature that I think was a design choice, right, Kreg, Kreg Hanning, to use the, what do you call those kind of connectors? Push.
Yeah, spring-loaded connectors,
Spring-loaded,
or pushed. Yeah, spring-loaded, I think, is like the search term that comes up with the appropriate parts. But yeah, we're really happy with arriving on those. And I think it was just out of this, like, not everyone has the right connector, not everyone has alligator clips. Alligator clips themselves are kind of finicky. They wobble around, they bump into each other and short out. So this just kind of provided a more stable experience without making it more difficult to use. And you can really jam, like, if you have regular old pin headers, the holes of this spring-loaded connector are just wide enough to fit the kind of casing around the pin header, so you can just shove those right in there. You could roll up aluminum foil or copper tape if you had to, and you could stuff it in the hole. So it's a pretty accommodating spring connector, which we're pretty happy with.
Yeah, it's really strong too. It's I was really surprised with that.
Dean, did you want the part number for the spring-loaded connector?
Yeah, they sound interesting. Yeah, please.
Yeah, I'm happy to share them. I ordered pretty much every spring-loaded connector that DigiKey had to offer, so I could test out how hard they are to press. And for those of you who have this in hand, you'll notice there's still a fair amount of pressure you have to put on the springs. They're not too much pressure, but you still have to put a good amount. And this was by far the lightest pressure spring connector I could find. Some of the other ones, you almost had to have pliers to be able to squeeze down and open up. But yeah, I'll share the part number for this one.
It's strong enough that I actually think like younger kids would have trouble pressing it.
They may, yes. Yeah, so I might have to get into industrial design and do custom connectors at some point, but for now, this off the shelf is a good enough solution.
Yeah, it's great.
Yeah, I bought out the last of the stock from DigiKey, so please don't swoop them out from under me, because I need a lot of them these days. But I will share the part number because we are all about open source.
If there's any other if anybody has anything else they'd like to share with that been working with the CraftyBit or maybe a little troubleshooting, we can troubleshoot at the end, of course, too. Okay, so I don't see, you can just put in the chat if you want at any point to share something. That's fine. All right, so maybe Brian, you were going to discuss, you had some thoughts on choosing the right tools for the job.
Whenever we're making materials like this, people always say, why are you using Logo instead of Python? Why are the CraftyBit instead of the microbit? That there's always there's a collection of this versus that I thought it may be valuable to get into a conversation about the various choices that people are making and why we're picking the choices that we picked. To get started on that, one question that even came up today already: blocks languages versus text languages. It's a really, really interesting trade-off. Blocks languages really are lowest barrier to entry, no question about it. What we found is with blocks languages, they're not quite as good for decomposing problems into smaller pieces. And Josh, you actually were saying that before the session got started. Do you want to repeat what you were saying?
Remind me which topic I was.
Blocks versus text and dots with dot with.
Oh yeah, just that that we found that this week it was easier to build up a tool that was much more complex using a text-based language, using art logo specifically, that we could write a procedure to draw a dot that we also could specify the size, the color, and the shade of the dot. There's a way to do that slightly with Turtle Art. There's a way to get one input into it. But with the text-based language, it was more natural. And
actually, you could drag a second one in, but not a third one. Nice. When we were primarily using making versions of Logo, it was much more normal for there to be more time to to be in workshops with mentors and learn about things. And we found that teaching and learning Logo takes on the order of tens of minutes, where originally, we had a meeting with some museum folks back in the early 80s, and they said, when you're first presenting this stuff, what do you do? And we said, we like having 4-day workshops, and in a pinch, we do 2-day workshops, to which they said, in our world, you have an hour. And if in fact you have an hour, there's no way one could not argue that a text-based language is better. You know, if in fact you're embarking on a journey that you're expecting to be spending hundreds of hours on that journey, then spending the text language, I think, will carry you further at the cost of there being a little bit more of a barrier to entry. You know, the barrier to entry is, I don't know, you've taught this with a lot of students, Josh and Alec, I don't know if you want to like try to quantify it, but it's not like learning Mathematica. You know, it's not like you have to take a term off to do that. And it's not like you need to have a class just about that.
No, it takes a very short time to learn the syntax, and then you're rewarded with the like depth of where that syntax can take you, and the combinations that you may not originally perceive of like how that, like today was the first time in Art Logo I ever used one of. Like I was trying to set it to the shade of one of the, one or the other. And so, there's a finite group of commands, but you can go really far with them.
Now, there's a related question, which I think may be really part of the reasons why we're even having this workshop, is Alec was reporting that somebody asked him, why should I learn Logo when I want to do Fab stuff? Now, here's what I think is the answer. Let me make a little bit of slightly bold claims. The first is coding is a wonderful material for Fab projects, and it's a material that's not getting enough attention. So I think in general, for doing Fab-like projects, there really is room for a little bit of programming. So that's the first part. If you're going to be buying into coding as something that's important for Fab, that the question then becomes what language to use. And I'd argue that for Fab projects, Logo is more of the right scale. The majority of things that people talk about instead are really computer science languages. And in Fab, we're not really doing computer science. And actually, I wanted to share with you a quote just for fun. Craig, do you have that slide?
Yeah, let me share it right now. Oops.
Back in the 70s, Dijkstra, who was kind of the one of the most major computer science professors in the early years, said computer science is no more about computers than astronomy is about telescopes. And I'm pretty sure what he was trying to say is the field isn't about the tools. The field is about what you do with the tools. So I wanted to bring that up to date and say computational thinking is no more about computer science than computer science is about computers. Sort of saying a lot of time when people are talking about computational thinking, if you actually look at the suggested activities, it's really very simple computer science. What I think we've been doing with Logo and with Scratch is it's about doing computational thinking, but about doing it in a way that computer science isn't a very big thing on the table. Actually, the attention was when we're having this discussion that people interrupt and share thoughts and things.
I just wanted to add to that, like the whole, I guess the thinking in the Fab Lab world is that you pick tools that match the projects you want to do, that you should be able to, investigate different kinds of tools and sort of figure out which ones work best for what you want to do. And I always found it interesting when I did Fab Academy that, I think, other people here would know better than I am, but I remember there was like a mention of Scratch, but I didn't see many projects that use Scratch or, some of the other kinds of programming languages. So it was a lot of, it was sort of nice to sort of like try and embed that in my project when I did Fab Academy, just to see what was possible. Does anybody else have thoughts on like on tool choosing the right tools for the project when they're teaching groups in or facilitating groups in a museum. You often have like an hour to work with them and get them going. So definitely.
I'll just quickly mention, there was a presentation, I think it was by the Fab Lab out of Columbia, and they had a presentation on recursion. Basically, they took a square and then divided each side in half and made a rotation. So they kind of had a square inside of a square inside of a square. And it was all very interestingly done, part of it in Spanish, so I didn't follow all of it. But, you know, they were using Rhino and Grasshopper, you know, which looked very cumbersome. And I sort of had the feeling, looking at what they were doing, you know, they could do this in the basic language that you're using here with turtle graphics with a lot less hassle. So anyway, that's, and like you, when I was taking Fab Academy way back in 2011, I think they were just starting to develop Scratch. And it was mentioned, but we never really used it much. It looked like a good idea, but we were mostly working with Python and things like that.
Yeah, I mean, I remember Fab Academy seeing a lot of really interesting like soft app development, you know, that was happening to try and simplify the fabrication, or to add, I guess, to add sort of tools to help build different kinds of fabbable objects. But it wasn't really, I wasn't seeing that on the programming side when I did Fab Academy. You're reminding me, so the Grasshopper Rhino, I kind of learned this stuff getting into MaxMSP, which was more of a programming environment for, I guess, initially for music, building instruments and software synths, and then adding visuals to that. And it was similar to Grasshopper, sort of a node-based kind of programming environment. And I still think very like the way I think about projects, often I get stuck in that way of thinking, and I try to apply it to like a text-based language. But I remember at Fab Academy, one of my challenges for myself was to connect MaxMSP with Logo on one of the AT-Tinies. And it was nice. It was a nice sort of like, okay, so my focus was on more using what I know in MaxMSP to build an interface, and then just the micro logo language that Brian was working with. Brian, you were showing me, that was micro logo, right? That we put on the AT-Tiny?
Yeah, no, it was a close cousin to what's on the CraftyBits.
Okay. Yeah, and I had a blast doing that, and it was just a simple IO element in that had to be addressed, and to figure it out, I still had to figure out that, you know, how to communicate on a more on a lower level, which was nice with the board. I'll just pull that up just so I can. So this project here, and just to show the interface. So here, you know, is the logo code. And so on the left is just a GUI I made in MaxMSP. And on the right is just connecting it with a custom board made in Fab Academy using Logo. And I don't know, I love that workflow. I remember Neil questioning why I was choosing MaxMSP, because there's it's just because it's what I knew. It's what I know how to use, and there's a lot you can do with it.
So I was reminded back when I first encountered processing of the claim, the tale that it was, you know, invented as a sketch pad, as it were, for artists to be able to quickly get their ideas into the digital realm. And it never, you know, even the idea of drawing a square was a little more cumbersome than Logo was. So that's why I've chosen to stick with Logo kind of as my prototyping all the way through to final production tool. And then just as people were talking too, I'm reminded both of Andrea's Turtle Stitch project, which is a spin-off of Snap, so another Logo derivative. But this one where you're fabricating embroidery. And I know Brian spoke earlier in the week about Paula's work behind the scenes to bring an implementation of the DST file format that a lot of these embroidery machines use to be able to export that directly from TurtleArt. But this has been another interesting realm to explore, both the code as a tool for fabrication, but then, you know, an area of fabrication that many of us haven't considered. You know, we've been caught up in lasers and 3D printers, but textiles are a very interesting and form of fabrication that have a rich history. The other logo-based fabrication environment I also thought of was Beetle Blocks, which is Eric Rosenbaum's, and I'm forgetting the other developer who sort of picked up the mantle of it. But that is, you know, logo programming, again, with a snap basis where you're fabricating for 3D printed objects.
Is that still active?
Yeah, I haven't really seen it move much since Scratch at MIT a few years ago, but they have it to a very working stage, and they have some really good documentation. You know, from anything from, I mean, I have a chapter in my second book that leads you through fabricating a vase, you know, using code. But I think the great thing about what they've done with Beetle Blocks is they have both, you know, practical as well as fantastical things. It might really push the boundary of what we're able to fabricate, but you know, that's the beauty of doing it in a digital realm, is that you can come up with some fairly fantastic shapes.
I haven't just posted a link. I'm just going to check it out. Yeah. Oh, there it is. Okay. So yeah, I haven't played with that, but I've had students working with oh my God, what's it called? Oh my God, programming. It's escaping me now, so I'm going to quit while I'm ahead.
I haven't played with it much because, again, TurtleArt does what I need it to do. But Tinkercad also has a whole code side now, that because Tinkercad is it's a kind of a low-end 3D modeling. It does most everything I need to do for the 3D modeling and 3D printing that I do. But they do have a whole code aspect of it. Rob Morrill, Morrill, I believe. If you look him up on Twitter, he's done a lot of curriculum and documentation around that, and a lot of work with his students that he shared on Twitter. That's definitely, you know, a logo-based geometric type of output, but again, in 3 dimensions. So very interesting.
I'm just putting his name up in the chat here. robmorrill.com, I believe. JSCAD, sorry, OpenSCAD. That was the one I was thinking of. Have you used OpenSCAD? Oh,
I used it once as part of a project to fabricate 3D printed records for the old Fisher-Price phonographs. But that's as far as I've taken OpenSCAD.
I used it in Fab Academy because that's what we had.
yeah.
But I'm using Fusion 360 now. But yeah, you know, you reminded me, of course, Tinkercad is a low end of like Fusion 360, and in Fusion 360, they have a scripting aspect, you know, which is kind of complicated, but I mean, it allows you to get under the hood and do certain things. It sounds like that's kind of the what they may have in Tinkercad. I'll have to take a look at Tinkercad because I suppose it's a text-based, but
the Tinkercad code is all block-based as well.
Yeah.
oh, it's all block-based.
Yeah, and so the
Yeah.
Fusion 360, I mean, that almost sounds, Dean, like that's almost going towards like an OpenSCAD with the scripting, right?
I think it is,
Yeah.
except OpenSCAD would be easier.
Yeah.
Yeah.
Nice.
The scripting is a nightmare, but I mean, if you look at the code, I mean, there's a lot there, but I mean, I think they've got 5 guys at Autodesk who work with it, but anyway.
Yeah, but the Tinkercad, it is block-based, so it'll scale down to younger students and remain viable for adults as well.
It's kind of like a micro world for CAD, right? And I mean, I don't know if that's a good description, but I find it to be a go-to, just like, 3 blocks can make something happen that you need to happen. Tinkercad for me is like, if I just need to connect a dowel or connect 2 dowels together, it's just a cylinder and done, so it's sort of fun to sort of mix the tools up, and I'm always mixing low with high, but partly it's like research too, pushing myself so that I have more ideas for students that I work with.
We have a group that meets once a week in Facebook where we're trying to figure out how to use Fusion 360. And one of the members always complains that, if he wants to get something done, he goes to Tinkercad because it's quick and easy. It's always kind of complicated in Fusion 360. But anyway, that's.
Yeah. And this is that's a good point, or it makes me think of something that I've had a lot of chats with Brian about. Like, usually Brian will introduce something he's working on, I'll play with it, and I'll be like, can you add this? And I'm always pushing what is the tool is meant for, maybe, or it's not, and I find with Tinkercad, the thing that bothers me, and I was talking to Kreg in our lab about this, like, I don't love the way that you can position objects together. I know there's a ruler tool, but I kind of wish you could more easily nudge objects according to I don't know if I'm wrong in that. Maybe I'm just not using it properly, but if you have a cylinder and you want to position something just a few millimeters off from the side, you have to pull out this ruler and do this, or you can drag it and then change the number directly. But there's little things like that you get tripped up when you're used to using something like Fusion 360 or parametric modeling tools, that you sometimes want in the smaller tools, not knowing that there's a reason why it's not there. Kreg, sorry.
I was gonna, do you mind if I throw in a pointer to a paper Mitchell and I wrote many years ago? Just because it kind of describes at least our design sensibilities. What the paper is thoughts about designing construction kits for kids. And property of the stuff that we put together is we try to make it have the feel of a construction kit more than having it have the feel of raw material. And what we did is in this paper, we go through a couple of informal design principles that we've kind of adopted more informally than formally. And one of the design principles, which I think turned out to be the most important in the designs that we've been doing, is choose your black boxes carefully. Mm-hmm. That you don't want to say that if you want to build something up, you have to build it out of molecular components. At the same time, you don't want to give people a finished racing car as part of the thing. You want to be somewhere in the middle. And in designing black boxes carefully, there's a bit of a question, and it's really an open question. How much do you black box the electronics? Right? Arduino blacks boxes it not at all. Microbit black boxes it either not at all or completely, depending on whether or not what you have is already on their board. Right? And there's an argument for keep things open because then it's infinitely flexible. There's also an argument saying, well, yeah, we want infinitely flexible, but we like the idea that to connect a NeoPixel, you just need to use some push pins. And that question kind of surfaces itself in figuring out about design of programming languages as well. And, since this whole session, I think, was about choosing tools, which programming language. And as with any choice of tools, it depends on what it is that you're trying to do. If you're trying to get kids to grow up to be professional programmers, then you probably don't want to start with Logo. So what percentage of kids do we expect to grow up to be professional programmers? Anybody want? I don't know what the number is.
I don't know,
but it's unlikely to be more than 1 in 20.
But that's counter to what there's a lot of pressure maybe on institution schools to have more people programming.
No, that's true. That's true. And it's the real distinction is, do you want the path into programming to be the path towards picking that up as a profession, or do you want it to simply be the path towards getting engaged in computational thinking? You know, I'd argue, and this is a discussion for a different day, the whole notion of computational thinking is really important. And at some level, you could say is for everybody, but yet nothing is really for everybody, but it's for as broad a community as we think that math is.
So yeah, that's an interesting idea. So you're saying math, like it's sort of like a math of another way of looking at.
I thought we had this at some of our prep meetings. The outrageous form of saying that is computational thinking is to the 21st century what mathematics was to the 20th. You know, that, and in fact, actually, Craig, do you want to pull up that Wolfram quote? The phrase computational thinking became the flavor of the month before anybody had taken the time to clearly figure out what they meant by it. So somewhere in the middle of this, Stephen Wolfram wrote a blog post about computational thinking. And in that blog post, here, let me read this. But first, let's try to define what we mean by computational thinking. As far as I'm concerned, its intellectual core is about formulating things with enough clarity and in a systematic enough way that one can tell a computer how to do them. Mathematical thinking is about formulating things so that one can handle them mathematically when that's possible. Computational thinking is a much bigger and broader story because there are a lot more things that can be handled computationally. And I think that really sums it up, is computational thinking is really about figuring out how to describe something systematically enough that you could explain it to a computer. And I'd argue that for a lot of problem domains, the computer science languages aren't as good as some of the non-computer science languages. That if you actually wander around universities and look at what languages the non-computer scientists are using for their projects, a lot of people are using R because of its statistics handling abilities. If you go to an engineering school, it'll be MATLAB. If you go to more science, it'll be Mathematica. The places where the traditional programming languages are being used is when there are research projects where they have a programming team that's trying to implement the problem. And the problem is described by the scientists and then just implemented by the computer people. So, you know, all of this to say, if you think that the first programming language should be Python or Java or JavaScript or C, I'd ask the question of what are the advanced uses of these languages that you imagine these kids doing in 10 or 15 years' time? Logo, what are the advanced uses in 10 or 15 years' time? Probably nothing, but the flip side is Logo, I think, actually will more quickly and more closely bring you to the core of computational thinking. Though, since it's a quote from Stephen, he'd argue that Mathematica is better at it.
And so, Craig, when you were thinking about this project for the CraftyBit, the idea of putting logo, how did that happen? Was that just through talking with Brian, or? I know we talked about it the first day, but there's some maybe some new people here that.
Yeah, and it was more or less an evolution. You know, we had done an earlier version of this with the micro VM that was purely block space. So it was using a microbit and a few other devices. And the only front end to it was a block-based front end. And then for this one,
you're not telling the most fun forward the story.
Right.
Craig came into it totally from the Scratch block space side. It turns out that we fell into a project where we're building something that we hope to send to the moon. And we decided to use the same micro VM for our moon launch project as for the computational thinking kit. Right.
Yeah.
And with
Brian,
that, we weren't really thinking of a block space language for, you know, space science. So yeah, we started implementing the technology at Logo, and it turns out that the technological overlap between that and what Craig was doing was like 98%.
Yeah. And then, yeah, I think through that project right now, I'm remembering that's when I really discovered the beauty and flexibility of the logo programming language, because I was one of these kids, like I missed the boat on logo entirely. You know, by the time I got introduced to computer science in school, it was C++. Things had kind of moved past logo. So I never got that early introduction to it through my schooling. But yeah, just through that moonshot project, this trying to send something to the moon, blocks of course didn't make sense. And I kind of discovered the beauty and simplicity of the logo
in
language.
fact,
So.
I seriously considered MicroPython for that project.
Yeah.
But this is almost literally true. The footprint of logo is about 1/10 of the footprint of MicroPython. And up there, you really have to worry about cosmic rays. And the more code, the bigger a target. The second point was, for a thing like that, for robustness, you really do want to understand every line of code that is in the project. Shelley said something about time, and I think that's totally key. Logo was designed under the assumption that you had enough time. Scratch was more designed under the assumption that you might not.
And I think that was a big barrier around when logo came in back in the 80s. To schools, like the training of the teacher, right? Because you would leave, like on certain levels anyways, you would sort of come in, facilitate it, this is logo, and then leave it with a teacher who didn't have the time to really integrate it or didn't do it in the right way.
But that's moving to a bit of a different thing. It's the real hurdle that we have to overcome with all of this at all levels is staff development.
Mm-hmm.
You know, that it's most educational environments don't invest enough staff development resources in these new kinds of technologies. You know, if the staff development is there, then the choices that we're talking about are relatively small. You know, if the staff development isn't there, things that are more plug and play work better.
Great. So you were talking about the Moonshot project. I don't know if you can share like a link or something, because you kind of glossed over what that was.
Here, let me see if I could find the place where it got started.
While Brian looks for that, I'll just swing back to Shelley's idea. And I did take a year, the first year that I went really deep with turtle art was with a grade 3 class. And I took the year and decided we're going to work in logo this year. And you know, I met with them for 45 minutes a week and just broke it into small enough chunks. And we were able to explore, you know, the screen turtle and turtle art, but also we had probots, which are little race car shaped robots that can hold a pen. And so we you know, played with it in the physical realm as well. But you know, we chose to sort of set other things aside and take that deep dive with that particular grade.
That's one of the things too, is like my time's always limited, but the other way I look at it is the scope, because I am their science teacher for their elementary career. So I get to see them from grade 3 to grade 6, and I can build on what we've already done the previous year. So I understand that investment time. And part of it is too, is what can I afford? Like I teach 8 different age groups in 18 different classes with closed autism classes in 3 different subject areas in 2 different languages. So it gets a bit tricky to manage. So yeah, but it is so delicious to have that ability to start dreaming in code, you know? After I did the Getting Unstuck, I did it with a bunch of friends. So we had that whole social support network. I was dreaming in code, and it was just so exciting to have these possibilities of block combinations start to percolate up. Like that was really, really cool.
And that doesn't stop, you know, like I yeah. I think for me, it feels like the closest thing to being a magician is to be able to just sort of creatively mix your code a bit and then see what happens. All right, well, I don't know if there's any more we want to add to this. We've got half an hour before we're supposed to stop, but that we can stick on. But is there anything else that we should add?
Could I, at the risk, when Josh was saying he took a year to learn turtle art, I could ask Josh to his experience on this. People often ask, how long does it take to learn turtle art? And the answer that I usually give to that is, I wrote the software. It took me a minute to learn the software. It took me about 2 months to start getting a sense of the materials and about 6 months to find my voice. And it really is the case that if you're embarked on a creative endeavor, the understanding of the tools is really small as compared to understanding the medium.
Mm-hmm.
So if in fact we want to be empowering kids with the ability to work with different media, the time thing, you have to make time. Having a hello world scale project in the first hour and think that you've accomplished a lot is really just beginning to scratch the surface.
And I've been painting with acrylic paint for the past 5 years, and I'm starting to find my voice. It's kind of funny that we're really patient with some mediums and so impatient with others.
Yeah, and the thing that's really crazy is the kind of creative coding is got a kind of similar style learning curve to painting, as in at first you're just learning how to like slop stuff on canvases, right? And then you're starting to learn how to do things with the stuff that you've slopped on canvases. And then you get to the point where you're turning ideas into images. And it really, for me to get to the point of turning ideas into images, it was a long slog. And the majority of that long slog was really more the artistic piece of it than the technological piece of it.
Mm-hmm.
And Josh, I think you went through a similar thing. Do you want to?
Yeah, I would say it took me about 4 years really to find like the style, and for my art to really seem not flat, as it were, but to have like some dimensionality to it and to begin to explore some themes. And I'm 9 years into it now, and continue to learn new things, continue to have fun with it, and I'm inspired enough that I hold groups captive and teach them over the course of a few days how to do it themselves. So it's a great medium in which to work. And I think the other thing, that I mentioned a bit earlier is when you start to really get into turtle art, you see it everywhere around you. And there's so much inspiration, whether it's the tiles in the kitchen or the fence slats outside, there's so much inspiration and so much is geometric in our world that there's a font from which we can all draw to create, to find inspiration to create.
Pre-pandemic days, for me, a big source of inspiration was summer clothing on the metro.
Mm-hmm. Yeah, I have a number of designs that are different, patterns on bags I've seen on the subway in New York City.
Yeah, no, it's funny though, because there is in the I'm sure you looked at it in the help there on the iPad Turtle Art. There's an inspiration section.
Yeah.
And styles of it. You could say what you've occasionally found inspiring. We went to see Kung Fu Panda, and after seeing Kung Fu Panda, we decided that palette of yellows and oranges. Right, Kung Fu Panda is visually beautiful. You could almost like take your glasses off and turn the sound off and just look at the colors. It's insane. So we ended up doing a few series of images that all it shared with Kung Fu Panda was the palette they chose.
That's very cool. I know that at one point Eric Nauman and Brian and I had a conversation around different artists who have influenced some of the turtle art that Brian and Artemis and Paula produce, and I took the time there's a list of them. And if that didn't bring the links,
Natalia Goncharova. We went to an art exhibit in Toronto one day, and there was an exhibit that was just, I forgot, it was some major Russian artist and his friends. And Goncharova was one of his friends. And when we got to the museum, her canvases were just the best. And I'd never heard of her. So I Googled for her, and the first thing on the Wikipedia page said the woman who sold a canvas for the greatest amount of money for a woman. And I thought, okay, my taste is somewhat, shared.
If you hit that PB Works link and scroll down a bit, that same list is reproduced, but there's links to a Google image search for each of those artists, just to give you a quick blast of, okay, here's the style of the artist. But it was cool to, and I've gone in my visits with Brian and Artemis, they've taken me to the art museum there in Montreal, and it's cool to see pieces up there on the walls. It's cool to see pieces in the metro in Montreal that have clearly influenced some turtle art. There's a piece of my turtle art that's the station floor on one of the stations near where Brian's home is. So lots of turtle art out there.
Brian, do you have any examples? I know you're wearing one, probably.
Oh no, the one that I'm wearing is of various artists. I could go get the cards.
Yeah.
The turtle art. Actually, while I'm.
So those who know Brian, every shirt Brian wears is a turtle art shirt.
Okay, yeah, I'm always wearing turtle art shirts. It's like a really clear example of our liberal reuse, which I guess is the most polite form of saying plagiarism, is actually, Josh, since you had that page up, could you pick the Toussignon page and do a share screen? And if you just scroll down a little bit, this is a somewhat obscure Quebecois artist who I think is great. And if you see the sort of slashes, and now I guess if you undo the share screen, and I could show the image that we did, is actually, why is I'm seeing you, Alec, rather than me.
Oh. I should be. I'm not. Is that the case for everyone?
No, I see the gallery.
Yeah.
Okay. But if you see, this was our reinterpretation of that image. And, so what did we do? And I'm sure, Josh, you found the same sort of thing. We found his angle a little bit too oblique, and I couldn't prevent myself from putting a dot after the slash. Right, just because a lot of us used to read slash dot, and if you're making slashes, it should end with a dot. And another one that this is a bit looser is Mondrian, but everybody knows Mondrian, and that's kind of a complete classic. But there's numbers of them.
What's nice about these tools, on the back side, you had the code there, so you can hand this out. And Brian, I mean, you have a lot of these. You can get, Brian has these, but you, yeah. So this is good for facilitation, because like we were saying, time is so important, Shelley, that you could easily get someone started by going through these cards, and they have like a little difficulty level, right? The single turtle is the easiest. And so it's sort of like, it's a very tangible and nice way to sort of, they have to recreate it. They can't copy and paste it, which is nice, right? That's a big thing with code, is that you can copy and paste it, but not really know what you kind of make mistakes that way, and you're not really sure, you don't get a feel for it as like a material. So in this sense, you have to just copy it, and students make mistakes, but they just have to be more observant you can point out where, you know, the mistakes, they usually can find their own mistakes by looking at the cards. So these have been very helpful for us at our school. And I know that Fiona.
I just sent you a link in your text.
Yeah.
Of the calendar that we made with the kids with Turtle Art 2 years ago.
I'm gonna
the cards they did copy, but it's still a learning process. Some of it is stuff that they actually then made themselves.
I'm going to try and get that. Is there a way you could put it on the chat in the Zoom?
I can try.
All right. Yeah, so Fiona is basically worked a lot with students in what, grade 5, you said?
These ones were grade 7, but I use Turtle Art from grade 5 through 7 in the classroom.
And then we fabricated the while you're looking that up, I can show the mobile that we made.
We make that every year except for last year for obvious reasons. But yeah, we do Turtle Art and then they make it into an SVG file, and then we laser cut it, and then they hang them in the classroom. And
you were trying, so for those who don't know, we've been saying Paula a lot, but Paula's Brian's partner at Playful Invention Company.
Yeah, the collaboration between the two of us is to the extent that everything is very pretty. She's like, we jokingly said that, you know, the way that we split the thing is she's the artist programmer and I'm the programmer artist. Though she's probably, you know, one of the best programmers around.
I'm just airdropping it to the Mac so I can show you.
Great.
But while you're finding that, why did we allow ourselves to go off on this tangent? A lot of the way people think about Fab is as a way to move into, what I get from the outside is Fab is about promoting invention and entrepreneurship. And what Alec and I have been discussing over the years, it would be great if there was a variant of Fab that was really about art.
I don't know how to do this. I don't know how to share it because it's a PDF, Alec. Can I put it in the chat?
Yeah. Oh, that's a good question.
Probably.
I think you can attach a file.
Or you could share your screen.
Yeah, I think I'm just going to open it and see if I can share the screen. It's opening in previous. Stop that.
I think this version of Zoom is restricting some of these things. I don't think upload.
Oh, really?
Yeah.
Let me share my screen. Otherwise, I'll just show you like holding my computer up too. Alec, do you have to let me share my screen?
It should be good.
Okay, there we go. So this is what they created. Like I said, they did copy some of the cards and things they found on the net, which is, as far as I was concerned, was fine. They are themed according to the month, so these are supposed to be Easter eggs. This was Mayflowers. This was School is Done for June.
Who's the fourth one?
The fourth one, what?
This is too much of an inside joke. Is I made the original version of this image with 3 of them, and the sizes of the people were intended to be in proportion to me, Artemis and Jasmine.
Okay.
And I know whenever I see it recently, my first reaction is, boy, Jasmine was grown.
As I said, the kids have just been duplicating what they found or creating and changing.
That last one that you showed is a beautiful riff on the original.
Yeah.
You know, this is, that's way nicer than what they copied.
So, and then that is Halloween, I believe. No, that's November for whatever reason. And this, oh, that's November. And then this one is, I think, completely original. Because it's meant to be a Christmas tree in the menorah.
It's great.
So anyway,
That's really fun.
that's what the kids created 2 years ago. We plan to do it again this year, so we'll see what they come up with. So anyway, there you go.
Awesome. Thanks.
Do you then print them and hand them out?
Yeah, we printed them, handed them out. They sold them to their friends for $5 and then donated the rest to the food bank.
Because when we print ours, we get ours printed on cardboard with a spiral binding, and it's in small quantities. They're like $10 a piece.
We printed them on cardstock and we spiral bound them ourselves.
Okay.
And then they, as I said, they sold them to their friends and family, and we donated the money to the food bank. It was their little project. So anyway.
Actually, it was with one of your students that we were, I think you were in the lab at one point, Fiona, and I'm just going to share. So this is, they just were playing with the randomizer and just hitting the iPad, you know, refreshing the screen randomly. And they were excited by that was an accident. They were just messing around, but they got excited by the animation, even though it was sort of, so they just kept pressing the screen, and that was sort of like a weird byproduct of working with turtle art that I think was a lot of fun too.
We actually did that last year, and I don't have it because it's on the kids' iPads, is you can actually screen record while you're in turtle art and then save it as a GIF. So they actually were running through their turtle arts doing the random thing where you tap on the screen and it switches, and then they created their own GIF of it.
GIF design.
It was pure accident and way too loud, but whatever, it worked. Anyway,
I wanted to share the turtle art tiles too, Alec.
Sorry, which?
So this is a project I conceived years ago, and then word got back to me through Jay Silver that Brian had seen this and was impressed by it, and that of course made my day complete. But what I did is, this is the second time I ran it. This was with 6th graders, but what we did is we programmed designs in turtle art that then we needed to work on. You know, this is really too complex. This is getting closer to where we need to be. Printed them on a color printer and played around with coloring them in. And then meanwhile, 3D printed the designs and used those designs to press them into clay. And then using their palette that they developed earlier, they glazed the tiles and we fired them. So that the tile is both art and it's code, you know, captured in clay. And I've run this project a couple times, and you know, it's always a delight to see the variety of designs that emerge. And it's a, you know, logo is allowing the students to create work that they would otherwise be incapable of creating because of the precision of the rotation and the repetition of it. You know, they've created a tool that allows for a much more sophisticated work.
I love the mixture of the digital and you know, manual work there. So maybe at this point, I don't know if there's George, you had an issue maybe that you wanted to show Craig. I don't know if anybody from Fab Lab Leon wants to ask questions about because they've had a couple of CraftyBits, but we can do a little troubleshooting now.
Yeah, I have just want to share with you something. Just 1 second, please.
Yeah, is that okay, Craig? Sorry, I'm putting. I didn't. Yeah.
Oh, that's great. Or is this you're talking to Craig H now?
Sorry, yeah, Craig H.
Yeah. Yeah, that'd be great. And I just put a link in the chat. If anyone wants, I added a sign up link on the CraftyBits homepage. If anyone wants to sign up just to get updates on the project. Like I mentioned, it's probably going to be a kind of a slow ramp up over the next 6 months, but probably in about 6 months, we'll be ready to start shipping more of these out. So definitely sign up for updates if you're interested.
Okay. My question is there like a way instead of, because like my personal story is like I came from a design background. I do for like 15 years motion design. So I work like with ad agencies and stuff like that. But the thing is, when I did Fab Academy, it was very hard for me to learn coding. Okay, so what I'm more into creative coding. So when I did like a small search, I found like processing is the best for creative coding. Okay, and after that, I noticed like if I want to publish things online, okay, I have to learn like processing.js. So it's like a JavaScript based environment. And when I wanted to learn how to prototype some games and stuff like that, also I had to learn Unity. Okay, but because Unity it's paid, I switched a little bit to Unreal Engine, which is it used like C++ language, and they use like a visual scripting tool called Blueprint. Okay, after that, because I wanted like to achieve, like I wanted to break into like doing like a mascot, and I want to animate, like I want to break into animatronic. Okay, so I found like this tool. Okay, it's like it's still in beta version, but it's like it's about like visual programming. So my question is there a way like instead of learning many programming languages, okay, to develop a tool like a compiler or converter? Let's say like if I know JavaScript, okay, I can do something like I can animate like a robot, okay, like somebody is using Python. I don't know like if this is feasible or not. I'm just like brainstorming an idea with it.
What you mentioned very many different things, and one of the properties is if you need a complex infrastructure for the stuff that you're doing, like Unity. If you take Unity 3D as an example, it's very hard to build a 3D engine that is really good. The real folks have done something like that, but Unity did a language choice, and for kind of high-end robotics, the people who actually develop the interface to the high-end robotics have a language choice. And there isn't really a terrific technology to do that. The examples that we've been showing are not built on top of a complex and elaborate infrastructure. So figuring out how to move things between languages gets a bit better in that domain. Alec keeps asking me to, okay, why don't we just extend logo to stream video, right? And the thing is the actual stuff that does the stuff is usually very specialist, and the language put on top of it tends to be an afterthought. But it sounds like from what you're doing, you've already invested a lot in learning how to program, which is good. Perhaps you're already finding, but if not already, you will, is moving between language. Learning a first programming language is hard, a second programming language is a third as hard, and a 15th programming language is almost no time at all.
I see.
Great. Yeah, it's easier. Okay, so we're pretty much at 3 o'clock. I don't know. I guess we can connect on the live basically live fablabs.io if there's anything you wanted to ask, or Craig put up the link to CraftyBits, right? to join the mailing list, perfect. And yeah, thanks everyone for these 3 sessions. I've had a lot of fun, and I know it's a big topic, and we kind of covered a lot of different things, but it's definitely nice to be meeting and chatting with everyone about it.
I had a quick question for Kreg. I finally got my microbit to work, and I saw that you had on the CraftyBits. It asked if it seemed to have a provision where you could use a microbit. So I guess my question is, do you have some kind of hex file that you drag over to make it work, or do we have to wait for your CraftyBit board to be available? Or
no, so you won't have to wait for it to be
how do we
available.
play on the CraftyBit? How do we play on
Yeah.
the CraftyBits before we get the board?
I know, and honestly, the microbit is a good kind of drop-in replacement, or not replacement, but you know, a suitable candidate to be part of this system. So yeah, as Dean noticed, I'll just share a screen real quick. You found this hidden kind of section. If you go up to the gear on the code section, you'll notice there's a few other boards that are available here, and you probably noticed that microbit was in the list.
That's what I clicked on.
Yep, is mostly ready. I haven't released the hex file for it just yet. It's just about ready. It needs a couple of tweaks just to be fully, you know, in sync with the rest of the system. So if you sign up with that email link at craftybits.net, I can send out an update once the hex file is ready to start playing around with that one. Because yeah, it's likely that you could play around with it some with the microbit before the Gio boards or the rest are ready to actually start shipping out. So, and this just comes back to that discussion point of, like, you know, how do we feel about other pieces of you know, hardware out there like microbit, like Raspberry Pi? And I think part of it is we just want to embrace them into this system. You know, they have great sensors, they have great design sense. So microbit, we kind of see it as just another device that can, you know, be integrated into this, and it gives you a great motion controller that you could use with some of the other boards. So it's not ready just yet, but hopefully very soon, and definitely a lot sooner than the Gio board will be ready to start shipping.
Okay,
Yeah,
great.
look for updates for that one.
That's the way to go. We just have to wait for a hex file and then drop it in, and then we can start playing on the CraftyBits site.
Yeah, and then you could use it just like it was an actual CraftyBit board. Yeah, minus the nice spring connectors, but yes.
Okay, without it.
Yeah.
Okay, great. Okay, well, thank you guys much for a great presentation.
Thanks, Dean.
Thank you.
Yeah, I just have a quick question. Like, I just wanted to put in. Actually, I was right now I was also building this, like, trying to figuring out like regarding the tools. So if I can share like what I use basically, or to make this, so idea came for like using cardboard as a way of like interacting with the kids. So this was just a package that came in, and like why not fit it inside I just have an Arduino inside it, and like I have IR sensor. But the fun part is like I have connected this to Scratch. So it uses the Sketch for Arduino firmware, and like, so basically as soon as if you can hear, can you hear it?
Yeah.
So it can have more functionalities to this. So like because Scratch has all those like motion and sound effects that you can add in. So you can have a like real world like storytelling sort of a thing that can be integrated. Like what I was also trying to work with some other Blockly also, like, but like on some other block based thing, but like they didn't have that kind of a like I can have speakers to do those kind of features. But like then again, like if I have a computer, if I'm using a laptop, why not those features? Like you can extend the capability of your whole system, like using all the other peripherals with of a computer. So yeah, so that was something like I was thinking, and yeah, it can. And also like the thing that we were talking that you guys were discussing about regarding the tools that you use for exploration. So what I come from, so just quickly let me introduce myself. I'm Dibjyoti. Like I'm working for a foundation called like Sparky Foundation. It's like I'm directing it. It's a makers. We're trying to like push the maker movement in the northeast part of India. So I come from Assam. So it's but a lot of like the rural population is more than 80%. So we have to, when talking about tools, like for us, it's always about availability and the cost of it. Like we cannot invest, like we had Lego programs running in only one center of this in this location, like and it was government funded basically. So no common school can like have a Lego kit or some sort of a kit which is very, very easy to use. So we are also working on like developing a very low cost, like for our range, for ours, like at least region, which can have a quick programming access like Logo and like Blockly, like drag and drop. So that is like for us, that is a main concern. And also like since I come from a place like which have like different vernacular languages, so kids don't learn in like only one language over here. We have like 5-6 different languages which through which they like learn. So English comes in only like as a secondary like lesson. I was in English school, so like I have like more of understanding, or I've been speaking more English. But then again, like when we go to places, these rural places, and we have camps and workshops, what we find, even like even me speaking the local language, like we have around 27, around like more than 10 tribes in our place. Like it's a tribal community, like we have living community. So language becomes a very big barrier, like for us. Like we cannot have just one language and like we communicate technology and like learning through just one language of communication. So for us, like having the communication through different language is also a very important factor. So while like teaching coding also, so that is also where thing we are thinking about. Like, so would it be wise to like teach a 2-year-old who is not yet like have a like understanding of English, to give him like those English like blocks written in English, and like how will they like correlate with those kind of things? So for us, like that is one thing we're trying to do, like to bring up like local languages in the programming base, so that at least they can get a kickstart about it, like what, and like they can relate it to the to a better version of it. Like just be like a stepping stone towards the world of programming and robotics and physical computing. So yeah, so those were some of the things, and we are still struggling to like find out the like right development tools basically to make all those kind of things. So it was really fun like to see all you guys like coming up with this idea, and like I'm just trying to like just thinking like how to get it like cost effective in this place, and like in a very comfortable language in my area. Thanks. Thank you all for.
Yeah, absolutely. Thanks for sharing. I mean, a lot of great ideas in there. And I think with the blocks language, we should definitely do localized languages for the blocks. So similar to what Scratch has done, where you can have a drop down of languages. Of course, then we need people in the community to provide high quality translations, which can be a bit of a challenge itself. Logo probably falls into like slightly different category in translations that we may not go down that path just yet, but it's definitely something to consider. And then for low cost devices, so we've run this same micro VM, that's what we were saying is kind of at the heart of all of this, on like really low end microcontrollers. So we have a version that runs on an ATtiny, so you could kind of wrap this into it, a whole circuit. You could build it yourself for under $1. One of the challenges that is like the ATtinys and the lower end microcontrollers don't have like radio communication, which we see as a really essential part of this product. So there's a question of what kind of things would we want to bring into the family and enable this for, but definitely the software that we've designed could run on a wider range of devices. Whether or not that fits within what we're calling the kind of CraftyBits family is an open question. But there's no doubt the software we've written could be adapted to many different platforms and devices that you might have. So definitely once we open source this, that's total possibilities. You could take this, kind of run it on an ATtiny or something real low end, and definitely run it, and run it on your own custom boards for sure. But yeah, part of the design of like the CraftyBit is, I mean, I always have cost in mind, and I've tried to reduce costs as much as possible in the circuit design, but even so, there's import taxes. A lot of folks just need to be able to produce them themselves, or in their own country. So I think it's it's a big concern of ours, and definitely something to keep in mind going forward. Yeah, so thanks for sharing that. That was great.
Thanks, man. Thank you all.
Awesome. All right, everyone. Thank you again. Unless there's any other questions, I'm gonna end the call now. Just to I have to catch another train, so to speak. But yeah, if there's it was great chatting with everyone, and we'll catch you around soon.
Bye.
Bye.
Thanks, everybody. Bye.